This is the third section of the Exponentials and Logarithms chapter, and it's about exponential modelling. And all this is basically taking our exponential equations and using them to model real life situations. We normally use them to model things where you've got some sort of exponential growth or decay, Yeah, so it may be radioactive decay. If you do physics, you'll probably know about that. It may be to do with growth of bacteria or virus. Yeah, lots of things can be modelled using this exponential growth or decay. Right, we have our formula here. T is the number of days since the pesticide was first applied. There's our units. So part A, use this model to estimate the amount of pesticide after 15 days. Well then, T is just 15. So the amount of pesticide is going to be 160 times by E to the negative 0.006 times by 15. Let's work that out. So 160 times by E, you need to do shift, and it's 2 buttons under the on button to get that E, and I get a long number. Well, what's the decimals? 146.22898. The amount of pesticide. Well, we could give 3 significant figures. So 146 mg per square meter, and that's 3 significant figures. It's normally acceptable. Part B. Now the meaning of the 160 in there is because when t equals 0, we will get p equals 160 e to the power negative 0.006 times by 0. So basically you'll get p equals 160. So it's the amount of pesticide at the start. Okay, so the amount of pesticide at the start before it started to go down. Part C, show that dp dt is kp and state the value of k. Right, so we will use this rule to help us differentiate. If y equals e to the f of x, then dy dx is f dash of x times by e to the f of x. So we just need to differentiate that power. When you differentiate that power with respect to t, you are just left with negative 0.006 times by e to the f of x. Like that. So let's work out what 160 times by negative 0.06 is. So 160 times by negative 0.006. So negative 0.96 e to the negative 0.006 t. So if we need to state the value of k, that means comparing this to the thing that we started with. And what we did to 160 was that we multiplied it by that negative 0.006. So that means that's the value of k, negative 0.006. Okay, part D. Interpret the significance of the sign in the answer to part C. Okay, so negative sign there actually means that we've got a negative dB dt decay is negative, which means the gradient is negative. And if the gradient is negative, it means that we have a decreasing function. A decreasing function. So if we've got a decreasing function because the gradient is negative, it means that actually in terms of the context of the question, it means that the pesticide is decaying, pesticide's going down. So I'll put pesticide decaying or going down. We've got some exponential decay. And part E, just a quick sketch of the graph here. Now our axis is going to be T for time, P for the density of the pesticide. And it goes down, doesn't it? Like that. Let's do it in red. Let's just do the right colour. So yeah, this one is decreasing like that, and it's decreasing from 160. Right, you should now be able to do exercise 14C on pages 318 to 319.